Today, we will learn reflection and symmetry. Look here. There is a mirror line in the center of the chessboard. Suppose we place an object in front of the mirror, we will see its reflection in the mirror. Here, we have placed the object in the third square from the mirror, and we can see that the reflection of the object visible in the mirror is also placed in the third square from the mirror. What does this tell you? Think a little. Absolutely correct. Reflection appears behind the mirror at the same distance as the object appears in front of the mirror. That is, the distance of the real object from the mirror and the distance of its reflection from the mirror is equal. Like length, if we talk about angles, the angle of the reflection and the angle of the real object are also equal. However, in one aspect there is a change. The right part of the object appears to be left in its reflection, and the left part of the object appears to be in the right of the reflection. This is called lateral inversion. In such a situation, we see that the object and its reflection are symmetric with reference to the mirror line. Thus, the mirror line becomes a line of symmetry. Let's understand it more comprehensively. Suppose we draw letter A on a piece of paper. If we fold this paper from the middle in this way, we will get two equal parts of A, the left part and the right part. Let us give the name PQ to the line formed by folding the paper. If we look here, the left half of A and the right half of A are exactly identical to each other. What does this tell you? Think a little. Absolutely correct. This shows us that A is a symmetric letter and PQ is a line of symmetry. Imagine that we have placed a mirror in place of the symmetric line PQ. In such a situation, the figure appearing in the mirror will be exactly the same as the half A hidden behind the mirror. Therefore, we can say that the left part of A, which is half A, and its mirror reflection are symmetric. We can also see that the distance of a point located on this half part of A to the left of line PQ and the distance of reflection of that point from the line PQ is the same. Keep in mind that here we are talking about perpendicular distance, that is, we will measure the distance from PQ at an angle of 90 degrees. Now, we can say that it is a symmetric shape or figure and the mirror line is a symmetric line. This type of symmetry, in which half of a shape is a mirror image of its other half, is called reflectional symmetry. In terms of this symmetry, we can say that the distance from the symmetric line of reflection of a point and the distance from that point to that symmetric line are the same. Keep in mind that a shape can have only one mirror line or symmetric line, and some shapes can have more than one symmetric line. In our everyday life, reflection symmetry has proved to be useful in many fields such as art, sculptural art, textile technology, design creations, architecture, etc. Let us understand this with some examples. The Taj Mahal is a famous example of architecture. In this, we see the use of reflection symmetry. Symmetry is also seen in items or objects used in our daily life. It makes the object look attractive. Do you know what a kaleidoscope is? A kaleidoscope is an instrument made using 3 or more mirrors in which a variety of attractive patterns can be seen. Many reflections are formed by mirrors that have several lines of symmetry. A rangoli is a suitable example of symmetry. While making rangolis, unknowingly, reflective symmetry is used. Observe the rangolis made during the festival and note the use of symmetry in them. Have you tried to make symmetrical shapes with paper? If not, do try. For this, take a piece of paper and fold it in half lengthwise. Then, draw half part of a pattern and cut it. Once you unfold the paper, you will obtain a full shape. If you fold a paper twice and cut a shape, you will see a symmetric pattern. So today, we learned reflection and symmetry. We will see some examples related to this in the next video.